The moon is a sliver of silver over a damp suburban alleyway. In the shadows, a mouse pauses. Every instinct inherited from millions of years of evolution should be screaming at it right now. The air is thick with the sharp, unmistakable scent of cat urine, the calling card of a predator, a death sentence in a bottle. Normally, this smell would trigger a frantic, heart-pounding retreat. The mouse should be vanishing into a crack in the wall, its tiny heart racing as it seeks safety. But tonight, something is very wrong. Or, from a certain perspective, something is going exactly according to plan. Instead of fleeing, the mouse twitches its whiskers. It doesn't look terrified. It looks curious. It begins to move, not away from the scent, but toward it. It's walking straight into the territory of its greatest nightmare. It's almost as if the mouse has forgotten what a cat is, or worse, as if it suddenly found its mortal enemy irresistible. This isn't a fluke of nature, and it isn't a brave mouse. It's a hijacked mouse. Inside its brain, a microscopic intruder is pulling the levers of its behavior, rewriting the rules of survival to serve a much darker purpose. Welcome to the world of Toxoplasma Gondii. I'm Ariel, and today we are peeling back the layers of a biological mystery that sounds like it was ripped straight from the pages of a science fiction novel. We are talking about a single-celled parasite that acts like a real-life mad scientist. It's a creature so small you could fit thousands of them on the head of a pin. Yet it has the power to manipulate the behavior of complex mammals. To understand how this works, we have to look at the parasite's ultimate goal. You see, Toxoplasma gondii is a bit of a romantic, but only in the most macabre sense. It can live in almost any warm-blooded animal, but there is only one place in the entire world where it can sexually reproduce: the gut of a cat. Think about that for a second. For this parasite, a feline's digestive system is the promised land. It's the only place where the life cycle can be completed, and the next generation of parasites can be born. But there's a problem. A microscopic parasite living in the soil or in a piece of raw meat can't exactly walk into a cat's mouth. It needs a ride, and that is where the mouse comes in. The mouse is the intermediate host, a temporary vessel used to bridge the gap between the ground and the predator. But mice are notoriously difficult to catch. They are fast, they are cautious, and they are hardwired to fear cats. So, Toxoplasma gondii evolved a terrifyingly elegant solution. It hacks the mouse's brain to make it want to be eaten. Researchers like Joanne Webster and Jaroslav Flager have spent decades watching this mind-bending phenomenon play out in laboratories. In a standard setup, you have a mouse in a maze or an enclosure. On one side, you put the scent of a neutral animal, like a rabbit. On the other side, you put the scent of a cat. A healthy mouse will spend all its time as far away from the cat scent as possible. It's an ancient, visceral fear. But when that mouse is infected with toxoplasma, the behavior flips. The mouse doesn't just lose its fear, it develops what scientists call a fatal attraction. It will spend significantly more time sniffing the cat urine, seemingly drawn to the very thing that will kill it. How does a single-celled organism perform such a complex feat of neurological engineering? It doesn't have a brain of its own, no nervous system, no hands to reach out and move things. Instead, it uses chemistry. Once the parasite enters the mouse's body, usually through contaminated food or water, it doesn't just sit in the stomach. It hitches a ride on immune cells, using them like tiny Trojan horses to bypass the blood-brain barrier. Once it reaches the brain, it settles in and forms tiny cysts. It's a permanent resident now, and it's ready to start its work. The parasite specifically targets certain regions of the brain, most notably the amygdala. If you've ever studied basic biology, you know the amygdala is the brain's emotional processing center. It's the smoke detector. When you see a snake or hear a loud bang, the amygdala fires off the fight or flight response. By forming cysts in this area, Toxoplasma Gondii essentially snips the wires to the alarm. But it goes a step further. It doesn't just stop the fear, it interferes with the brain's reward system. Research suggests the parasite can actually increase the production of dopamine, the chemical responsible for pleasure and motivation. Imagine the terrifying brilliance of that. The mouse smells a cat, and instead of its brain saying, "Danger, run!" the parasite-induced dopamine surge says, "This is interesting, this feels good, go closer." It's a complete inversion of the mouse's reality. It turns a survival instinct into a suicidal drive. And the most chilling part, even if you were to somehow clear the active infection, the behavioral changes often remain. Studies have shown that the rewiring is so deep that the fearlessness can become a permanent part of the mouse's personality. The parasite has left a lasting scar on the host's consciousness. Now you might be thinking, that's a fascinating story about meat and cats, Ariel, but why should I care? Well, here is the kicker. Toxoplasma gondii isn't just a rodent problem. It is estimated that up to 1/3 of the entire human population is currently carrying this parasite. That is billions of people. We get it from many of the same sources: handling cat litter, eating undercooked meat, or eating unwashed vegetables grown in contaminated soil. In most healthy adults, our immune systems keep the parasite in a dormant state. It sits in our muscle and brain tissue as tiny, quiet cysts, rarely causing any noticeable illness. For a long time, doctors thought it was a latent infection, meaning it had no effect on us at all. But recently, science has begun to look closer. If this parasite can rewire the brain of a mouse to make it take more risks, could it be doing something similar to us? We are mammals, after all. Our brain chemistry is remarkably similar to that of a rodent. While we aren't exactly running toward lions in the street, researchers have found some uncanny correlations. Studies have looked at people who test positive for toxoplasma and compared them to those who don't. The results are, frankly, a bit unsettling. Infected individuals have been found to have slower reaction times and a significantly higher statistical likelihood of being involved in traffic accidents. It's as if that danger alarm is just a little bit muffled in humans too. There's also the entrepreneurship study. A few years ago, researchers surveyed thousands of university students and business professionals. They found that people infected with toxoplasma were 1.4 times more likely to major in business and 1.7 times more likely to have an emphasis in management and entrepreneurship. Among professionals, those with the parasite were more likely to have started their own business. Why? The theory is that the parasite reduces the fear of failure. Starting a business is a huge risk, and many people are held back by the rational fear of losing everything. But if you have a microscopic passenger whispering that everything is fine, you might just be more likely to take the leap. It's important to be careful here. Correlation isn't always causation. We aren't saying that every successful CEO has a cat parasite, or that every car accident is caused by a microscopic intruder. But the sheer volume of data suggesting subtle behavioral shifts is hard to ignore. Some studies have even linked the parasite to more serious conditions, like schizophrenia or increased impulsivity. It raises a profound, almost philosophical question. How much of our personality is actually ours? If a tiny parasite can nudge us toward being more reckless or more outgoing, where does the parasite end, and where do we begin? Think about the implications for our understanding of free will. We like to think of ourselves as the captains of our own ships, making logical decisions based on our experiences and values, but nature is full of these puppet masters. There are fungi that turn ants into zombies, wasps that turn spiders into web-building slaves, and here we have toxoplasma, potentially influencing the human psyche. It suggests that we are part of a much larger, much more interconnected biological web than we often care to admit. We aren't just observers of nature. We are the environment in which these tiny dramas play out. As we continue to study Toxoplasma Gondii, we are unlocking secrets not just about parasites, but about the brain itself. By watching how this organism hacks the amygdala, we learn more about how fear works. By seeing how it manipulates dopamine, we gain insights into motivation and addiction. This tiny mad scientist is actually providing us with a roadmap of our own neurology. It's a reminder that in the world of biology, size doesn't determine influence. The smallest creatures can have the biggest surprises up their sleeves, and sometimes the things we can't see are the ones truly in control. So, the next time you see a cat lounging in a sunbeam, or you're cleaning out a litter box, take a moment to think about the invisible world swirling around you. Think about that mouse in the alleyway, making a choice that defies millions of years of logic. We live in a world where the line between predator and prey, between host and guest, and between mind and body, is much blurrier than it seems. The story of Toxoplasma Gondii is a testament to the strange, beautiful, and sometimes terrifying ingenuity of evolution. It's a story that reminds us to stay curious, stay cautious, and maybe, just maybe, be a little more mindful of the microscopic passengers we might be carrying along for the ride. And that is the true wonder of science. It takes the things we take for granted, a mouse running away, a feeling of bravery, the behavior of a common house pet, and reveals the hidden mechanisms underneath. It shows us that even in a simple suburban backyard, there are battles being fought and minds being manipulated on a scale we can barely imagine. I'm Ariel, and thank you for joining me on this journey into the microscopic. Until next time, keep your eyes open and your mind, whoever is actually running it, curious.